Hello students, welcome to AIMS India online classes. This is a chemistry session. In this, we are discussing about the chapter Language of Chemistry. In this session, we are going to discuss about practice sheet related to this chapter Language of Chemistry. Okay, this practice sheet contains single correct answer type questions. Let us see the first question. The abbreviation used for the full name of an element is called. What is it called? The abbreviation or the shortcut which is used to name an element in the chemical reactions and equations. The shorthand representation of the element name is called symbol. The simplest form or the abbreviation of the name of an element is called its symbol. To make it easier and to make it convenient, scientists they have suggested symbols for the elements instead of writing the complete name of that element in chemical reaction equations. Okay, it is symbol. The symbolic representation of name of a compound is known as. Yes, in the same way how it is given symbol for the element's name, in the same way the name of a compound is also given some shortcut name or short representation. That symbolic representation of the name of a compound is called it's a formula. For example, if you say hydrogen, it is an element. Instead of writing hydrogen HYDROGN in all the chemical reactions, scientists they have suggested a short form representation of this hydrogen, just writing H. So if you write in chemical reactions, if you write H, that represents the element hydrogen. In the same way, the compounds or the molecule of compound also is given a simple representation, or that is called symbolic representation, the short form representation of the name of a compound. It is called formula. For example, if you see calcium carbonate, calcium carbonate. If you write in the chemical reactions, calcium carbonate with complete spelling, it becomes very lengthy. So to make it convenient and shorter, scientists they have suggested formulae for the chemical compound's name. How this calcium carbonate can be written by using symbolic representations. CaCO3. Just it represents the compound calcium carbonate. This CaCO3 is called the formula of that compound. So formula is a symbolic representation or the short form notation of the name of a compound. The names of compounds which do not follow any systematic rules are called. Yes, while discussing about the namings of chemical compounds, we told at the last there are certain compounds and they are having certain names which do not follow any systematic rules. They are given commonly based upon their sources and their uses and they're based upon the properties. For certain compounds, some names are given in general. So actually, they do not have any peculiar rules in giving that name. But because of the familiarity, these are being continued nowadays now also. Those names are called, yes, what are they called? They're called tribal names or common names. Okay, actually it is tribal names or common names. Both will come under, we can say both. These two will be correct answers. Tribal names or common names. Now the answer will be B, not this. It will be both A and B. Tribal names or common names they are called. For example, if you see sodium chloride is a chemical compound and it is most commonly called common salt. It is also called table salt or rock salt. So these are the based upon the uses and its properties. These names are more familiar. So even though it is having the chemical compound name sodium chloride, it is most familiar with its common names or tribal names, which are common salt, table salt, or rock salt. Okay, these are called tribal names or common names. Next, the valency of hydrogen in hydrochloric acid. Yes, what will be the valency of hydrogen hydrochloric acid? The formula of hydrochloric acid is, as we know, it is HCl. We know chlorine valency is 1. By reversing crisscross method, we will get the valency of hydrogen also as 1. Because if you see here, the valency of chlorine should come as 1. So from here, the 1 if you reverse, it will get as 1. So the same number which is down to the chlorine also will come to hydrogen. This is also equal to 1. Now the valency of hydrogen is 1. In terms of electrons also we can say, as hydrogen has only one electron, it will form valency 1 in its compounds. An atom or group of atoms which can exist independently with charge are called. Yes, the atoms or a group of atoms which can exist independently with charge are called. What are they called? The charged particles are called ions. The atoms or group of atoms with a charge are called ions or radicals. For example, if you say sodium plus ion, Na plus. Na plus is a sodium ion. So the charged particles are formed by either gaining of electrons or by losing of electrons. These charged particles formed by the atoms or group of atoms are called as ions or radicals. Here it is given ions. Next, the ions formed by the gain of electrons are called. Just now we told ions are formed by the either gaining of electrons or by losing of electrons. So based upon this, gaining and losing, ions are of two types again. The ions formed by the gaining of electrons and the ions formed by the losing of electrons. The ions which are formed by the gaining of electrons are called anions, and the ions which are formed by losing of electrons are called cations. So the ions formed by gaining of electrons are negative ions, negative charged ions. They are called anions. The ions formed by the loss of electrons or by losing electrons are positive charged ions, which are called cations. Okay, here ions formed by gaining of electrons are anions. Next, bivalent ion among the following. What does it mean here, bivalent? Bivalent means bi represents two. Bivalent means the ions with the two charge. Say out of these given ions, which is having valency 2, nitride ion. Do you know the formula of nitride ion? Yes, it is the ion formed by nitrogen. Nitrogen forms its ion by gaining 3 electrons. So here the valency is 3. Nitride ion valence is 3, not 1. Okay, not 2 it is asked here. Next, phosphide ion. Phosphide ion formula or symbol is P minus 3. So phosphide ion also having valency 3. It is also trivalent ion, not the bivalent. If the valency is 3, then it is called trivalent. Okay, now if you see chlorine, just now you have seen in this case, chlorine ion formula or symbol is Cl minus, means it is formed by gaining of one electron. So its valency is now 1. So it is called monovalent ion. What about sulfate ion? The formula of sulfate ion is SO4 minus 2 or 2 minus. This is a sulfate ion. What is valency in this now? 2. This sulfate ion has valency 2. So it is called bivalent ion. The ion with valency 2 is among this sulfate ion, SO4 minus 2. Sulfate. Okay. Nitride and phosphide are trivalent ions, whereas chloride ion is a monovalent ion. Next question. What is a correct definition of valency? What does it mean by valency? Generally, elements which are having 8 electrons in their last shell are stable. Those elements which do not have 8 electrons, they are unstable. So to become stable, they will try in different ways. Some elements, they will become stable by losing electrons, 1 or 2 or 3 electrons, which are there in their valence shell. Some elements, they gain electrons to become stable, and some, they share electrons. So these, the number of electrons gained or lost or shared by an element is called its valency. It is simply also called as the combining capacity of an element. Okay, valency is defined as the combining capacity of an element. This combining capacity is nothing but the number of electrons gained or shared or lost by an element in becoming stable. Okay, it is just to say the combining capacity of an element. Suppose if I say sodium, it is ready to lose one electron to become stable. So we can say its valency is 1. That means its combining capacity is 1. Okay, the combining capacity of an element is called its valency. Sodium forms dash ion. Yes, we told just now. Sodium forms dash ion. Generally, sodium is having only one electron in its valence shell. So the sodium will be ready to lose that one electron and forms a Na plus ion with 1 unit positive charge. So the ion formed by losing of one electron is called now monovalent electropositive ion, or monovalent cation also it can be called. So valency is 1, so it is called monovalent ion. Mono nothing but 1. Monovalency means valency is 1. So sodium is the ion formed with one valency. Okay, monovalent ion is sodium is monovalent ion. Next, identify phosphate ion among the following. Observe here which is phosphate ion. This is a phosphide ion. If the ion formed by a single element by the non-metal, then for those elements at the ending there will be ide, phosphide, nitride, fluoride, oxide. These are the ions formed by the single element. If along with the non-metal there are oxygens also, then they will get at the ending 8, 8, this all. If you observe, this is a phosphate ion. Phosphate ion is PO4 3 minus, and it becomes as one oxygen is being less, it is called phosphite ion. It is 8 ion. If there is one oxygen less, then it is called ite ion, phosphite ion. Phosphate, phosphite ion, and phosphide ion, single atom. Okay, this is about phosphate ion. Phosphate ion is PO4 3 minus. Next one, which one of these is monoatomic gas? What is the meaning here? Monoatomic. Mono represents one. Atom means atom, single atom. Monoatomic means single atomic gas. The gas which is having only one atom in its molecule is called monoatomic gas. Generally, the gases which we call as noble gases. Noble gases are monoatomic gases. Okay, no, which is the noble gas among these? Yes, helium. Helium is one of the noble gases, so it is monoatomic gas. Its molecules are having only one atom in their molecule, so they are monoatomic. Okay, next one. Atomicity of ozone is. What is atomicity of ozone? What does it mean here? Atomicity. Atomicity represents the number of atoms present in one molecule of an element is atomicity. So some elements that are having only one atom in their molecule, some they have two, some they have three, and some they have more than this. Based upon these, elements are classified in different types: monoatomic, diatomic, triatomic, polyatomic in this all. Now, what kind of element is this ozone? Is it Monatomic, triatomic, or diatomic? We know the molecular formula of ozone as O3. It means there are 3 oxygen atoms in one molecule of ozone. So ozone is triatomic and its atomicity is 3. Ozone is a triatomic gas. It has 3 atoms in each molecule. So atomicity is 3. The formula of the formula NaCl represents, I told you directly the name, sodium chloride. The formula NaCl represents sodium chloride. How do we say? This comes under first type binary compound. Means the compound which contains one metal ion and a non-metal ion. So these are called type 1 binary compounds. While naming the binary compounds like this, first we write the name of the cation. What is cation here? Na plus or Na. It is representing Na representing here sodium. So sodium is to be written first. Next, anion name. This Cl represents here chlorine. So root word from the chlorine is taken into the name chlor. Chlor is written. Chlor is taken from the name chlorine. Now, at the end of this second part, ide is attached. Now, totally it becomes sodium chloride. So, it is a name of this compound NaCl, sodium chloride. Okay. First, we write positive ion's name. Next, negative ion's name. Root part of this negative ion's name is taken from its element name. And at the end id is attached, so we get the complete chemical name for that compound. Okay, right, sodium chloride. NaCl represents sodium chloride. Next, which of the following elements can exhibit more than one valency? Yes, we studied about variable valency. Some elements, they exhibit more than one valency often. Those elements which can exhibit more than one valency are called variable valent elements, and that phenomenon is called variable valency. See, which element generally can exhibit more than one valency among these? If you observe elements like sodium, magnesium, aluminum, they can exhibit always single valency. Suppose if you see sodium, it always exhibits one valency. Magnesium exhibits two valency. Aluminum can exhibit three valency. But if you see in case of copper, copper can exhibit more than one valencies. It can exhibit two valencies, one and two. It can exhibit two different valencies. So this kind of elements which can exhibit more than one kind of valency are called variable valent elements, and this phenomenon is called variable valency. Copper can exhibit two different valencies, plus one and plus two, in its compounds. Okay, copper is correct answer here. Next, which of the following molecules is not triatomic? Triatomics means, what is meant by tri here? Tri represents 3. Triatomic means the element with 3 atoms in its molecule. Observe once which is not having 3 atoms in its molecule. You see, it is nitrogen dioxide, it is called. There are 3 atoms, 1 nitrogen, 2 oxygens. So it is triatomic. If you see carbon dioxide, 2 atoms of oxygen and 1 atom of carbon. So it is also triatomic. If you see MnO2, 1 atom of manganese and 2 atoms of oxygen. So it is also triatomic. If you see magnesium oxide, MgO, in this there is 1 magnesium atom and 1 oxygen atom. Totally only 2 atoms are there. So it is a diatomic molecule. It is not a triatomic molecule. It is diatomic. So it is not the triatomic. Okay. Next. Let us see the next question here. If you see the valency of magnesium in magnesium chloride, what will be the valency of magnesium in this magnesium chloride? so that we can identify from the valency of chlorine. We know the valency of chlorine is 1. From this compound, if you write a crisscross method, the 1 present here will come to chlorine. So the valency of chlorine itself, it is already 1. So this 2 will come as the valency of magnesium. So the valency of magnesium is 2. Okay, next. The valency of iron in ferric chloride is, we know iron is also one of the variable valent element, means it can exhibit more than one valency. They are, iron can exhibit two valencies generally, plus 2 and plus 3, two valencies. So if an element exhibiting more than one valency, if it is exhibiting two valencies, then the ion with lower valency is named by attaching OUS at the end of its name. And the ion with greater valency or higher valency is named by attaching IC at the end of its name. Now, iron can exhibit to plus 2 and plus 3 two valencies. The ion with plus 2 charge is mentioned as Us, and the ion with plus 3 valence is mentioned as ferric. Now they're asking about the valency of iron in ferric chloride. So this ferric represents the ion of iron with higher valency. The higher valency of iron is 3. So the valency of iron in this compound is 3. Ferric chloride means the chloride of iron in which the valency of iron is 3. Okay, let us go to next question. Which of the following elements is not trivalent or tetravalent? Tetra means 4. Tetravalent means the element with valency 4. Generally, carbon group or carbon family elements, they exhibit valency 4. This carbon, silicon, germanium, they all belong to same family or same group. These all elements exhibit valency 4. Now, only phosphorus is not an element with valency 4. It can exhibit a valency 3 only. We write the formula of phosphide and as a P minus 3. So its valency is 3, not 4. So it is a trivalent element, not a tetravalent element. So phosphorus is correct answer. Okay, next. Next one. What is a symbol for element lead? What is a symbol for element lead? Yes, actually, in writing the symbols for the elements, Berzelius has given some instructions in writing the names or symbols of the elements. One of them is the first letter of the element's name is taken as its symbol. For most of the elements, the first letter from their name is taken as symbol. And if this first letter is already existing as symbol for some other element, then second prominent letter also is taken into its symbol along with the first letter. So in this way, symbols are given for most of the elements. But for some elements, around 11 elements, they are having their symbols from their Latin names. For example, it is given here lead. Lead is having its symbol from its Latin name plumbum. So plumbum is its Latin name. So in that starting letter is P. But this P is already the symbol for phosphorus. That is why along with the first letter, second prominent letter B also taken from its name, Latin name. Now the symbol of lead is Pb, plum, because it is derived from its Latin name plumbum. Okay, not only for lead, nearly 11 elements they are having their symbols from their Latin names. For example, sodium, it is having its symbol Na. It is derived from its Latin name natrium. And one more element, potassium. Potassium Latin name is kalium, so its symbol is K. And some other elements like iron. Iron Latin name is ferrum. So its symbol is taken from it as Fe. And in the same way, copper, its Latin name is cuprum. So Cu is its symbol. Gold, Au is a symbol because its Latin name is aurum. So in this way, so for some elements, symbols are derived from their Latin names. One of them is lead also. Its Latin name is plumbum. So its symbol is Pb. Next, name the compound CaF2. How to name the compound? And it is also binary compounds and type 1 binary compound. Metallic ion and non-metallic ion are present. So if a compound is given like this, first we write the cation name. So here Ca is from the element calcium. So first we write calcium. And next the root word of anion name is taken. So here the anion is of F represents fluorine. So the root form of this fluorine is taken as Fluor, fluor. So calcium is from Ca, fluor is from fluorine, F. Now at the end of the second part, ide is attached. Now it becomes calcium fluoride. The chemical name of this compound CaF2 is calcium fluoride. So as it is a type 1 binary compound, need not to mention the number of cations and anions. Number of atoms of either cation or anion need not to mention. So it calcium fluoride itself, it represents one atom of calcium and two atoms of fluorine in the molecule. So it is calcium fluoride. Next, the compound carbon tetrasulfide can be named. Okay, I have given the name directly. CS4 can be named. So if you observe in this compound, there are two non-metallic atoms. So this comes under third type of binary compound. So while naming the third type of binary compounds, first we write the name of the first non-metal. Here the first non-metal is carbon. First we write directly carbon. And before this, we keep a prefix which represents the number of atoms of this non-metal. If it is 1, need not to mention anything. We should not mention mono. If it is more than 1, then the number of atoms of that non-metal should be mentioned before as prefix, before the name. Okay. Now, if you see second non-metal is sulfur. So from the name of sulfur, root part is taken as sulf. Now, at the end of the name, ide is attached. So carbon sulfide. But there are 4 carbon atoms, 4 sulfur atoms. That number of sulfur atoms also should be mentioned in between these two. That is, as there are 4, should be mentioned as tetra. So it becomes now carbon tetrasulfide. Totally 4 parts. First one is first non-metal name. Directly it is written as carbon. Second, second non from the second non-metal name, root part is taken. It's sulfur. S represents sulfur. So from the root part, sulf is taken. Sulf. And at the end of this second part, ide is attached. It becomes now carbon sulfide. But there are more than one sulfur atoms, so a prefix to be attached to this before the sulfide, which represents the number of sulfur atoms in the molecule. There are 4 sulfur atoms, so the prefix becomes tetra. Carbon tetrasulfide is its name. Where is it? Yes, here. Okay, let us see the next question. What is the correct chemical formula of the compound copper 2 oxide? So here this 2 represents the valency of copper in this compound. As copper is a variable valent element, the valency of copper in this compound is prescribed in the bracket as Roman number. It represents its valency 2 in this compound. Now if you say copper plus 2 oxygen or oxide formula we know as O minus 2. If you write the formula by using crisscross method from these two, we get first what we do in the crisscross method. First we write the positive ion followed by negative ion, and then we take the common factor from their valencies. Maximum common factor is eliminated. Here 2, here also 2. Now 2 is eliminated, and then signals or symbols or plus and minus symbols are omitted. Now the remaining numbers are crisscrossed. Here 1 remain, here also 1 remain. It becomes CuO. Copper 2 oxide formula is CuO. Okay, next. What is the correct chemical formula of the compound carbon dioxide? So, carbon dioxide. If you observe, the first non-metal is carbon, and the second one is ox, which represents oxygen, and both are non-metals as it is oxide representing. And next, dioxide, which represents two atoms of oxygen. So, it is good. 2. CO2 is a chemical formula of the compound carbon dioxide. Okay, CO2. Where is it? Here. Next, chemical formula of zinc hydroxide. We know zinc ion formula is Zn plus 2, and hydroxide is a radical or ion with a group of atoms OH minus. Now, if we write the molecular formula by using crisscross method, what do we get? No common factor. So this one will come to this, and this two will come to this. Now, as there are more than one atoms, it should be kept in the bracket. We get it as ZnOH taken twice. So this is the formula of zinc hydroxide. Next, valency of carbon in carbon dioxide molecule is valency of carbon in carbon dioxide molecule. Just now we have seen carbon dioxide molecular formula. So it is like this. We know the valency of oxygen is 2. So we should get here 2. So here nothing is there, means 1. If to make this 1 as 2, these 2 should be multiplied with 2. By this, when you reverse the crisscross method, we get here 2. On this total becomes the valency of carbon. What is that? 4. So the valency of carbon is now 4. Okay. Next. Give examples each of the following. See, some compounds names are given and they're asking to give some examples for this kind of compounds. What is the first one given? Binary compound. Give an example for the binary compound. Binary means what? The compound with only two kinds of atoms in its molecules. Can you give an example? Yes, see here NaCl, which represents sodium chloride. In this, there are only two kinds of atoms, sodium and chlorine atoms. So, sodium chloride is one of the binary compounds. Next, monovalent elements. So, what are monovalent elements? The elements with valency 1 are called monovalent elements. Can you give examples for the monovalent elements? Any? So, here. Sorry, not this. Hydrogen, valency of hydrogen is 1. I think they have given here monoatomic. So monovalent element is hydrogen, chlorine, sodium. These all will come under monovalent elements. Let us see examples for divalent elements. Yes, oxygen valency is 2, magnesium valency is also 2, sulfur valency is also 2. So these all will come under divalent. The elements with valency 2 are called divalent elements. Next, diatomic gases. Diatomic gas means the gas which is having two atoms in its molecule is called diatomic gas. Can you give an example for diatomic gas? See here, hydrogen. In this molecule of hydrogen, there are two atoms of hydrogen. So it comes under diatomic gas. Even oxygen also having two atoms in its molecule. Okay, these are all coming under F2, Cl2, N2. These all are diatomic gases. Okay. Next, trivalent element. Trivalent element means element with valency 3. Any elements are there like that? Yes, there are some. Nitrogen, aluminium, these elements are having valency 3. So these are called trivalent elements. Next, triatomic gases. Triatomic means the gases in which there are 3 atoms in each molecule are called triatomic gases. For example, ozone. In the molecule of ozone, there are 3 atoms of oxygen. So it is a triatomic gas. Okay. Next. See here. Find the valencies of the underlined elements. Let us try to find the valency here of barium. By crisscross method, you can find easily. We know chlorine valency is 1. And if you crisscross that, here there is 1. So the valency of chlorine is obtained as 1. And this number will come as the valency of barium. What is that now? Valency of barium is 2. Here also, if you observe the valency of iron in this FeO, we know the valency of oxygen as 2. So we should get here 2. To get it here 2, but here only 1 is there. So we have to multiply these 2 with 2. So it becomes 2. It also becomes 2. These 2 will come as the valency of iron in this compound. So the valency of iron in FeO is also 2. What is the valency in this now? The valency of oxygen is 2. We should get here now. So we are getting this. Now this number directly is the valency of this element. So the valency of iron in Fe2O3 is 3. What is the valency of sodium in NaO? We know the valency of oxygen is 2. So we get this as 2 now. So this number, whichever is here, that is the valency of this element sodium. That is 1. Valency of sodium is 1 in this. Next here, the valency of sulfur in this compound. We know the valency of oxygen as 2, should get here 2. But here only 1 is there. So we have to multiply these 2 with 2 in both. So that we get valency of oxygen as 2. So this number, whichever we get here, is the valency of this second element, sulfur. So the valency of sulfur we got as 4, not 2. It is 4. Valency of sulfur in this compound is 4. Next, if you observe here, the valency of nitrogen in this NH3. We know the valency of hydrogen as 1. So the number here is the valency of hydrogen. We got directly 1. So this number is the valency of this element, nitrogen. What is that? 3. Valency of nitrogen is 3. Okay, in this way we can find out the valency of the unknown element by using the valency of the known element in the compound by reversing the crisscross method. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates and recorded videos. Thank you.